Okay, for this section we're going to look at, we've just looked at arithmetic sequence, which is sequences which are going up or down by the exact same difference, common difference. Geometric sequences are sequences which go up by or down by the same ratio instead. So if we look at this sequence here, we can see that the numbers are going up by an order of 2 every time. So they're being multiplied by 2 every time. And the way you can tell that is if you get 168 and you divide by 84, it gives you 2. And if you get 84 and divide by 42, it gives you the same number. Okay, so in other words, un divided by un minus 1 equals r, and r is a common ratio. So just like you had a common difference, now we've got common ratios instead. And with the common ratio, we can find more terms in a sequence. So in order to do a sequence with a common ratio, you have to have a rule or a recurrence relation. So a recurrence relation is one way of showing how to write a sequence. So you always start with un plus 1 to mean the next term equals un times r. Okay, so that means the current term times the ratio. Let me just annotate that with the meaning of each one. So this is the next term, this is the current term, and this is the common ratio. Okay, so in the case of the sequence above, we've got un plus 1 equals un times 2, or 2un. Okay, and you can see the neat and tidy version there. So that's the recurrence relation for any geometric sequence. And just like in arithmetic sequences, sometimes we want to find the nth term. And by that I mean we want to not just go to the next term along, we want to go like 10 or 100 terms ahead. And in order to do that efficiently, you need to have a general formula to do it. So for any geometric sequence, the general formula to find the nth term is un is equal to a, which is the starting number of the sequence, times r to the power of n minus 1. And just like with the arithmetic sequence, it's n minus 1 because you already are starting with the first term. So you need to do it one less time with the power there. So let's just see how this actually works in practice. So for example, if I want to find the 10th term to the sequence above, so I want to find u10. Okay, first of all I need to have the general rule for me. So the general rule for the sequence above is un equals, the first term was 42 times r to the n minus 1, and so r was 2. Okay, so this is the rule for the sequence above. I'm just going to label that. This is the rule for sequence above. And the one on the right here is the general formula. So this works for everything. That's why it's called general. It works for everything as long as you substitute in the right value. So we're going to use this rule now to find the 10th term. So u10 is equal to 42 times 2 to the power of 9. And what this does is it effectively, we're going to do it with the calculator, but it effectively times this by 2 9 times. And by doing that, each time you times it by 2, you're moving along the sequence one more time. Okay, because you're going times 2 times 2 times 2 times 2 times 2, etc., all the way to the 10th term. So that's why the power works. Okay, and we don't need to do it 10 times because we already started at the first position. Alright, so n10 is that, sorry, u10 is that. And so u10 equals, and we're going to use the calculator to do this, 42 times 2 to the power of 9. So that's 2.5 to the power of, sorry, times 10 to the power of 4. 2.15 times 10 to the power of 4. That's what the capital E4 means. So that, in other words, it's got 4 zeros, so we can hop this decimal place along 4 times. 1, 2, 3, 4. So it ends up being 2, 1, 5, 0, 0. Okay, so it's quite a large number in the end. So geometric sequences tend to do that. If we were to plot a geometric sequence where n is on the side there, and un is up the side there, and n is there. Okay, it tends to do that if you have a number bigger than 1. Okay, and it's particularly in the case of this one. Okay, the last one we'll do is first order sequences with 2 steps. We'll do that in the next video.